During the two EC225 ditchings, an oil pressure alarm came on in the cockpit. The emergency cooling and lubrication system was activated by the pilots and operated properly. However, an emergency lubrication warning light came on and resulted in the crew making the decision to perform a controlled sea landing as required in the flight manual.
Hello, I'm Jean-Brice Dumont. I'm the Chief Technical Officer of Eurocopter, and as such, I'm accountable for the design of our products, and in particular the EC225. We, Eurocopter, are well aware of the consequences of the impact this issue has on our industry, on your industry, and on the passengers' confidence. Since the beginning of this crisis, we have undertaken an unprecedented effort in terms of analysis, of tests, of ground tests, of flight tests, mobilizing more than 100 engineers by day, sometimes by night, in the weekends, during holidays, to get to the cause of these events and to find solutions. This video is about explaining to you this effort, what we've done, the solution we've found, the cause, in order to best regain your confidence.
In a helicopter, all dynamic parts are subjected to fatigue during their use. These parts must be designed with enough safety margins to ensure that there should be no failure with any parts during the lifetime of each helicopter. The investigation's objective was to understand which parameters reduce these safety margins to nothing during these two ditchings and what caused the emergency cooling and lubrication system false alarm. The cause of the emergency cooling and lubrication system false alarm has been identified. This false alarm resulted from a wiring problem which has now been solved. In the frame of the investigation, and as no stone has been left unturned, Eurocopter is performing additional technical and maintenance improvements on this system. Regarding the investigation on the EC225 main gearbox bevel gear vertical shaft, Eurocopter's opinion is that the crack initiation in the welded area resulted from the combination of three factors. All three factors must be present to initiate a crack.
We are convinced that the Eurocopter findings in terms of the root cause analysis are correct, and we are in a process in closing out all the really kind of failure tree branches.
Factor 1 and 2. Residual stress and hotspots. Many parameters influence a part resistance and its safety margins. The geometry, the material, heat treatments, production process, flight loads, and any alteration that could occur all along the life of the part. In particular, residual stresses resulting from the welding process contribute to reduce the fatigue strength in this welding area of the main gearbox bevel shaft. On top of this, highly stressed areas, so-called hotspots, exist on the welding area of the current EC225 shaft, which result from the shaft geometry. These hotspots equally contribute to reduce the fatigue strength of the shaft. Factor 3. Active corrosion. Detailed examination of the crack showed the presence of corrosion pits at the origin of the crack's initiation. Corrosion is an unusual phenomenon in a main gearbox, as all the parts are highly lubricated. The occurrence of corrosion is not enough to explain such a reduction of the bevel gear safety margins. So many tests have been conducted to identify the additional parameters that cancel the safety margins. The main factor has been identified and explained: the presence of moisture trapped in confinement of the welded area in direct contact with the bevel wheel during in-flight solicitation. In the area where moisture is trapped, an exceptional phenomenon called active corrosion develops and grows over time, leading to a weakened material after several hundred hours of flight. The residual stress and hotspots factors, even in the presence of classical corrosion, are not sufficient to initiate a crack. To initiate a crack, all three factors, above all the active corrosion phenomenon, must be present. Once a crack has initiated, it gradually grows or propagates around the circumference of the bevel gear vertical shaft. The safety measures proposed by Eurocopter are divided into two categories. Preventative measures, redesigned welding hole plug as well as manual and automatic cleaning should prevent any crack initiating. Precautionary measures, ultrasonic non-destructive inspection and in-flight permanent monitoring of shaft condition. These additional measures provide a simplification of monitoring and detection means to ensure that if there are any cracks, they are detected early, well before they have had time to grow to the point at which they could threaten the integrity of the bevel gear vertical shaft. By employing this combination of preventative and precautionary measures, the bevel gear crack appearing and not being detected has a probability of occurrence of 1 in 1 billion. This is 100 times more than what is required by the certification authorities. Final fix. Eurocopter will introduce a new design of shaft which will address all contributing factors and will significantly increase the strength margins. The long-term solution will not be available for 1 year and will take another year to implement across the fleet, so the safety measures will allow the aircraft to safely fly over water first.
Why aren't we waiting for the long-term solution? The measures we are putting in place today, which are preventative and precautionary measures, are fully ensuring safety and will eliminate the risk of further ditching due to a shaft rupture. The long-term solution will, among others, have as a goal to alleviate this maintenance burden we are today imposing on our customers.